Hello everybody, this is Yaquin from Yaquin's Lab, and you can find me on Facebook, WhatsApp, Gmail, and contact me too directly. For designing electronic circuits, you need power supply of 9 volts basically. 1.5 volts batteries are also available in market. For that you will connect them in series, but better to purchase 9 volt batteries, because electronic circuits work on DC. Most of the electronic circuits require 5 volts or 6 volts, basically 5 volts. That's why you should utilize a voltage regulator that will maintain a regulated 5 volt voltage for the electronic circuits. These are 3 terminal devices, and when with time your battery value decreases from 9 volts to say 8 volts, and then after 2 months to 7.5 volts and 6 volts and up to 5 volts, it will constantly maintain. The 7805 regulator will maintain the 5 volts output to the electronic circuits, and the 7806 voltage regulator will maintain the 6 volts regulated voltage for your electronic circuits. And after that, when the battery goes below 6 or below 5 volts, say it is 4.5 say, then it will cut off the whole circuit, and basically finally you see that, or you observe that this these voltage regulators are protecting our electronic circuits and components from damaging. Okay, so basically we need power supply in the form of DC, pure regulated DC power supply of 5 volts or 6 volts. These are with the help of the combination of battery and regulator. Battery should be with the connector. You can see the connector for your own convenience, and these are the connecting wires at input and output sides for your own convenience. Else it will be better for having these wires and connectors. Okay, now coming to the basic components of the electronic circuits, without which you cannot start or initiate your circuit designing concepts, are resistors. Okay, resistors are basically passive components that waste or dissipates the electrical energy in the form of heat. It is a 2-terminal device and it is non-polar. Okay, you can connect like this or like this, no problem, but they are color coded and shrinked at the center of their body. And the color coding, while you are doing lots of practical 2 or 4 or 5 or 6 or 10, then you will be familiar to that. Okay, picking okay, I can say this is 1 kilo ohm resistor. Okay, orange. Okay, orange, this is 33 kilo ohm resistor. Okay, what is this? Brown, black, red, this is 1 kilo ohm resistor, and brown, black, orange, this is 10 kilo ohm resistor. Similarly, you can directly pick out. You don't have to calculate by the formula BB Roy, Great Britain, very good wife, like that. Okay, so these are fixed resistors and 2-terminal devices. They are used to bias a component or reduce the value of current. Okay, okay, but there exist variable resistors also. I have a potentiometer, a small size potentiometer. It is a 3-terminal device, one for input and the other for ground. The separated third terminal is to be given as output, and from where you control the resistance of this potentiometer? By this knob. Rotating this knob by the screwdriver also, you can control the value of resistance being fed to the proceeded circuit. Okay, some of the different resistors also exist in market in electronics world, and they are some the resistors whose value depend on light are called light dependent resistors, whose value depends on heat are called heat dependent resistors or thermistors. So for that we have LDR. First I can let you see LDRs. LDR look like this, and these are light dependent resistors. Whenever the value of light incident on them falls, the value of these resistance vary. Similar is the heat dependent resistors. The value of heat controls the value of resistance being fed to the And so these resistors, heat dependent resistors and light dependent resistors, are basically being utilized in electronics world as sensors to develop sensor circuits, sensing the heat to protect a particular circuit from getting burnt up, sensing the light. These LDRs are utilized to develop light sensor circuits to sense light, and accordingly they bias a transistor or an IC. We will study, we will know further about transistors and ICs. It doesn't matter. These resistors, these variable resistors, are acting as sensors and controlling and giving us control the output of a electronic circuit. Okay, so these are the power supply regulator combination. After that you learned about, you knew about resistors and potentiometers. We also have variable resistor in the form of rheostat, but it is a very large and robust size. It is a 2-terminal device, and the third terminal is in our hand, and we slide the third terminal on its body to control the resistance value, and the operation and working is same. LDR and thermistors or NTC are working as sensors. One of these sensor is IR sensor. It is a 3-terminal device. It is a 3-terminal device. One is for input, the other is for ground, and the third terminal is for output. Okay. And IR sensor basically senses infrared radiations that being emitted out from silicon carbide or radiators and IR lasers and beams. The infrared values vary from 0.75 to 1000 micrometer, the wavelength, which is invisible for us, but can be sensed by these IR sensors. So these also are very important to develop sensing circuits like remote control, satellite communication, and IR imaging. These things are very important to develop the circuits. Okay, electronic circuits. So these are basically the sensors. You have got the inputs in the form of power supply, and as the human body have sensors, 5 sensors, similarly we also have to depend on the sensors of electronics world. So basically we have LDR, thermistors, and IR sensors, also called photodiodes, and it's also called photodiode. After that we have the one of the other basic component that is called, everybody is familiar about this, capacitors. Okay, capacitors are also of 2 types. Basically, ceramic capacitor, that is non-polar. You can connect like this or this, doesn't matter. But polar capacitor of, what is this? Wait a minute. It is 100 microfarad, and okay, this orange one is 47 microfarad. Wait a second. Okay, this is 47 microfarad. So these capacitors, these are electrolytic capacitors, and they are polar capacitors. The long leg is positive and the short leg is negative. Accordingly we have to connect them in circuits. But why we use these capacitors? Basically capacitors are open circuit to DC, but they basically filter out the AC components or pulses present in any signal. They basically ground the AC. We don't have learnt about how to ground an AC, but hypothetically capacitors, what capacitors are doing? Capacitors are grounding or filtering the AC components or pulses present in some sort of signals. So these are very, very important for providing pure DC signal to our electronic world, electronic circuit. Okay, now coming to the semiconductor world, and this is diode. This is diode. Diodes are basically passive components which act as switch, and they are also two-terminal device, and the wider black part, white black strip is positive, and the gray thin one is negative, and they are basically polar in nature, so their polarity must be checked with before connecting. But why we use these diodes? Diodes are basically utilized to act as switch, and they are the first electronics device in the world of electronics engineering, and after that we will be discussing about the transistors and then the ICs. But these two diodes, either even light emitting diode or simple diodes, general purpose diodes, they are packaged with I1N4007. they are general purpose diodes. They come like this and they convert our AC supply to DC. If we do not have these batteries, then we have our home supply of 230 volts that is very high for our electronic circuit. So we will step down them to 909 or 1208. It is 909. Okay, it is 909. So we will having 9 volts. If this is a transformer is a static device that either step downs or step ups the AC voltage. So AC voltage, we are in our home getting 230 volts and it is a step down to 9 volts. If we are having one extreme terminal and center tap terminal connection, we are having 9 volts. If we are taking two extreme terminals, then 9 plus 9 is 18 volts we are getting. So this is 909 is a transformer, another is 12012, 607, whatever we require, the packaging is available like that only. Okay, but this transformer maintaining at constant frequency, the transformer gives AC as output. What device we do have in electronics world to convert that AC to DC, to put it in our electronics circuits? These are diodes. A combination of diode, either half wave or full wave, we can form a rectifier circuit. This rectifier circuit will convert these transformers AC output to DC. But these DC that has been converted by the diodes from AC to DC are having pulses called pulsating DC. These pulses are to be filtered out. These AC components are to be filtered out with the help of what? Capacitors. Some other type of diodes also exist and has been designed. These are light emitting diodes. They are for signaling purpose and like that. Okay, and they are very important. This will show where is the current flowing and where is not, the current is not flowing. So these diodes, red or yellow or green, whatever. Okay, one more thing. The LEDs, the light emitting diodes, they are also obviously work on forward bias condition. The longer leg is positive and the shorter leg is negative. If both the legs are equal in size, then there are flags inside the body. There are flags, two flags. The shorter flag is positive and the longer big flag is inside the diode. The big flag is negative. Okay, but we cannot stick only to diodes and capacitors and resistors and sensors to develop a good electronic circuit. For that, a revolution occurred after diode, and that was transistors. 3-terminal active device that act as a switch and act as an amplifier, can be utilized to form amplifier, can be utilized to form oscillator, can be utilized to form ICs. We will study ICs after that only. So transistor packages are basically the general purpose transistor, as I do have right now, are NPN transistors and PNP transistor, and currently for starters, newcomers, they should use NPN transistor package BC547 package are the transistors. So transistors have 3 terminals. One is put it like this, form the D shape. The upper one is collector, the lower one is emitter, and the central one is base. And the best configuration for initial circuits is common emitter configuration. The input side should be forward and the output side should be reverse. And transistors basically are controlled by a current control device. Whenever the base is open, the current does not flow from collector to emitter and no output is obtained. But when the base is biased either with the help of thermistor or LDR or IR, photodiode or potentiometer or resistor, okay, whenever the base has been biased, then only the collector to emitter current flows, and at collector we get the output in the form of LEDs connected with the help of resistors. Okay, we will discuss it further, the working of transistor. But after some time another revolution occurred. Okay, just remind you about one thing. Transistors were invented in 1947 by three scientists, John Burdeen, William Shockley and Walter, and all of them three got the Nobel Prize in 1956 for the invention of transistors, basically because transistors are the actual revolution. Diodes are the base of electronics engineering and semiconductor engineering, but transistors are the revolution for the electronics engineering. So they got Nobel Prize in 1956 after inventing transistors in 1947 when India got independent too. Okay. What are the advancement of transistors? Are the ICs. The advancement of transistors are ICs. Various ICs, a lot of ICs are there in market, but the first IC was invented by Jack Kilby in 1958. The first IC was invented by Jack Kilby in 1958. For this too he got Nobel Prize, but in 2000. So late. So he did. Okay, doesn't matter what we do. But after the invention of IC by Jack Kilby in 1958, another revolution in the Department of Electronics Engineering has been revealed, and after that only another scientist I should mention here, Moore presented the golden law of electronics engineering called Moore's law in 1965, and he stated that the number of transistors that can be implemented in an IC per inch square will be double every year. The number of transistors that can be implemented or installed or fabricated per square inch of an IC will be double every year, and this is still being followed and obviously obeyed, because as soon as we get the latest inventions and discoveries of inventions obviously of electronics engineering and chip designing, we see that everything is being minimized in size, and electronics world basically is the definition. You can say that the controlling of electricity and electron flow and minimizing the power requirement, minimizing the space, increasing the reliability, increasing the accuracy, minimizing the weight, minimizing the size, everything. So these are the basic components of electronics engineering, and these are enough for a newcomer to start his own lab for designing electronic circuits from basics to higher logics, and for that you need some logic devices too, but I am talking about only the basic components of the electronic circuits. Okay, one more thing, the ICs, currently the head in charge of the electronics circuit designing and electronics engineering are ICs and transistors. ICs are basically the chip, silicon wafer based chips on which a number of logic arrays and a number of transistors can be implemented and installed. Okay, So the use of transistor has completely or partially completely been reduced and replaced by the ICs, the use of ICs. Currently I am showing you the 8-pin ICs. ICs come with bases, IC base, to protect their pins not being broken when you insert them into your breadboards or PCBs. But 8-pin ICs, there are 16-pin ICs, there are 40-pin ICs, there are a lot of number of ICs, and generation by generation the development in these ICs has been increased, has been done, and still it obeys the Moore's law. Okay, first generation of ICs was in 1964, I think, when 1 to 10 transistors were installed on one chip. But after that, in second generation, in third generation, in fourth generation, and we are currently in fifth generation from 1984 to onwards, where it is called ultra large scale integration, in where above 10 lakh transistors are being currently installed on single chip. 10 lakh transistors. Okay, I can tell you that, I can explain you about these in next videos, but currently for a basic student or initiative, we have basic ICs, and these basic ICs are LM358, LM339, LM358, IC741, which is operational amplifier. LM358 is a dual comparator operational amplifier, 555 timer. So these and lot more, these ICs are these three ICs are enough for starter to start his own electronics laboratory and work on electronic circuits and designings. One more thing, the importance. Okay, I tell you some miscellaneous things about the electronics tools. You can see this is, where is my pen? Okay, this is iron rod for soldering, and this is the PCB circuit designed by me. Okay, but PCB circuit designing should be done, and I suggest PCB circuit designing should be done after the breadboard cross verification. Breadboard will allow you to undo your actions. Wherever you did a mistake, you can check it and you can cross verify and undo your actions. So you should have 2 or 3 or 4 breadboards for your circuits to work on. The other tool, the most important tool, you can see digital multimeter. Okay, one more thing, don't use transformer. Transformer converts the 230 volts AC to 9 volt AC. Then you will design a bridge rectifier circuit to convert it into pulsating DC. Then you will filter it, and then you will find the 9 volt pure DC, and then you will connect the regulator to have 5 volt regulated pure DC. I suggest you purchase a battery, have a pure 9 volt DC, regulate it to 5 volt. That's it. No need of diode, no need of transistor, because it is somehow for a starter it may be hazardous if you have some electric connection of that range, because 5 volt and 10 volts and 9 volts are not so hazardous for us, but mistakenly you can have your you can damage yourself. So avoid currently before doing 5 or 10 experiments, avoid using transistors, and I tell you, avoid using PCB construction and soldering iron, because PCB construction, soldering iron and its lead and tin alloy, metal alloy of 200 degrees Celsius of melting point, and its flux that helps for soldering. These setup are required for PCB circuit designing, but what I am telling you, just do your circuit on breadboard. And what type of other tools you required and miscellaneous apparatus you may be required, not these things. You should have a screwdriver set, you should have some wires connections, maybe some switches be required, some bug strips should be required, the IC bases may be required for saving your ICs, wires are very important. What is this? Okay, this is holder, and what is this? This is also holder, and this is straighter too, straighter. If you can straighten your leads. Okay, so these are the basic things that are required for a starter student to start his own laboratory. One more thing, these are buzzers, and this is a snipper. A snipper will help you cut your wires and snip the insulation too. I don't think it's not enough. It's enough. It's enough. This is motor. Okay, this is motor I do have, but it's not very important for starting an electronics laboratory. For a fresher to start and start constructing his own circuits. In next videos I will show you and demonstrate you how to develop new basic electronic circuits, and how to design sensor circuits. Just remember one thing and clear your concept about that. As our body has the power of food, we need food for energy, and after that we sense the mosquito biting or slapping or snake biting. We can sense, and accordingly our brain gives the response. Similarly, ICs and transistors are our brains of electronics engineering. Currently ICs, you can say ICs are our brain of electronics engineering, and ICs are controlling the outputs. Outputs are in the form of buzzers, LEDs, and LCD also. I'm not showing you the liquid crystal display and 7-segment display, but LEDs and buzzers are enough for starting an electronic circuit, designing an electronic circuit. What are the inputs? Without any input, no output can be provided by the brain. So the inputs are the senses: light sense, heat sense, infrared sensing, these things, and the resistors are just to bias the things, and everywhere they are present in the circuit. And capacitor, you know everywhere. So these things are required to start a lab in your home and start designing your own basic electronic circuits. This is again Yaquin from Yaquin's lab. Thank you.